Can you get it to work?
Yeah, just give me a second.
Okay, that's fine.
Um, okay, let me share my screen directly.
There you go. Perfect. Thank you. Go
Yeah,
ahead.
thank you. Hi everyone. Thank you for joining this talk. I'm Chuan, a PhD student at Washington State University. In this talk, I'm going to introduce my research work, data-driven situational awareness for distribution system. This work is guided by my advisor, Dr. Anurag Srivastava. And in this talk, I'm going to briefly introduce the distribution system situational awareness and talk about three-stage situational awareness that include event awareness, DR, IBR awareness, and network awareness. Um, so first of all, I'm going to talk about the meaning of situational awareness. So the situational awareness is a step that we can use some features or system signals to know the current state of operations. So it is important to take actions to preserve system reliability and security. Meanwhile, the diversity of energy use in the distribution system now makes the operation become more complex. Like the figure I'm showing this slide, the energy generation has become diversified, especially solar and wind energy will become dominate the renewable power generation in the future. Uh, this complexity, that means the complexity of grid operation that will be increased. Therefore, the objective of this work is to improve situational awareness according to actual grid state and endpoint measurements to make the grid more reliable and sustainable. So first of all, so the situational awareness firstly was introduced by Ainsley in 1988. He states that situational awareness contains three levels. They are perception, comprehension, and projection. In modern power grid, these three levels are still applicable to achieve state of situational awareness to assess actual state of system. In addition, the situational awareness at present involves many aspects, such as hardware, software application, real-time measurements, environmental factor, and the data communications. So first of all, I'm going to talk. In first stage, I'm going to talk about event awareness. That is include PMU data, anomaly detection, and anomaly classification. Furthermore, I'm going to talk about event classification. The distribution system structures are really complex, and there are many data available. So how can we use those data to improve the inside of the system is still a challenge. When we get the measurement, we need to understand the meaning behind them. So that will allow distribution system operators to make the better operational decisions. Still, there's a lot of change in the event awareness that include like a lack of high resolution measurements, lack of accuracy for a practical system, and also as there are a huge number of events appears in the distribution system, we need to distinguish. We need to um, labeling them and get learn more detail of them. So the first in PMU anomaly detection, when this anomalies in PMU's measurement can affect the many aspects, such as the model validation, topology detection, state estimation, and even event analysis. So the challenges in PMU anomaly detection include there's a large of data quantity, and there's some dynamic operations and unexpected anomalies. Also, there's the data appears the spatial temporal behaviors. When we're using the machine learning technique to do the anomaly detection, we need to further consider how do we estimate those hyperparameters. This optimization is still challenging, and we need to further consider how to figure them out. So to do this PMU anomaly detection in my work, I tried the different machine learning technique, and I summarized those, especially for popular machine learning techniques in a table. So this table shows the strengths and shortcoming of these 4 techniques. Such as DB scan. The advantage of using DB scan in anomaly detection is the DB scan technique is good to separate clusters based on different densities, and that's DB scan is well used to handle the outliers. But the shortcoming of the DB scan is in some cases, such like high level noise environment, the DB scan cannot handle them very well. But if we use another technique, such like net local outlier factor, we can get the outlier score for those anomalies and process them in a better way. So the idea I'm showing this table is since each method has their own benefits, and also they have shortcomings, we proposed an ensemble method to combine those strengths and overcome those shortcomings. So the ensemble method will perform in a better way. After the anomaly has been detected, we need to further consider to classify them, since in anomalies, this also contains the bad data, and other than bad data, there's events inside those anomalies. So the ideas of anomaly classification is to distinguish them. The bad data usually refer to noise and sensor malfunction, also such like PDC failures or PMU estimator errors. Also, that could be some cyber-related bad data, such like GPS spoofing and communication failures, missing data, such like that. But for situational awareness purpose, we only need the event data. So we want to filter those bad data out. Then we propose this way to do the anomaly classification. So we in this stage we can get the pure event data in the anomaly for further process. So so after after filter out those bad data, we get the event for event classification. So basically, most of events can be captured from detection algorithm. Then we will use the classification machine learning technique to assign the labels to those events. So in this technique, we requires feature selections. That's part of signal processing, and the method include a single stream. The feature selection can be include single stream features, multi-stream features, and detection features. So after PMU, after that, I'm going to talk about the DER and the IBR awareness. In this section, I'm going to talk about solar power forecasting and solar power, the amount of application about solar power forecasting in colo pickup. So the motivation of to doing that is the growing use of solar energy in USA. That's solar forecasting in operation, and power market is still it's very still growing. Solar power forecasting also is very important. It can be used for PV modeling in distribution simulation that can improve the situational awareness, which can further be implemented to situational projection. So our work is to implement the machine learning technique to predict the solar power. The one of work we did is develop the long short-term memory model. This is one deep learning model. We use the TensorFlow to do this PV forecasting. So instead of using the original LSTM model, we improved the LSTM model by adding a Bayesian inference in middle layers. So with autoencoder, that's in this work the LSTM the PV power forecasting model we developed has a better forecasting accuracy, as shown in the figure 3 in the right-hand side corner. So we compared our model with different deep learning models, such as the feed-forward neural network, the deep neural network, and persistent model. So the error metrics we're showing here demonstrate that the model we did is gives a better forecasting rate. Also, the application of the PV power forecasting model can be used to model to do the modeling in the distribution simulator. Where one application we did is we implement the IBRs in colo pickup estimation. So the idea is we combine the different model into the case study where for example, that's very important since when doing the restoration, if some PV losses, that can be increase the load demand. So in this case, we combine our model, the IBR, the PV forecasting model, and the short-term load forecasting model. and the exponential Clopika model together to did the simulation. So at the results I'm showing this slides, if we consider the DER in the restoration process, and the result considering DER in the restoration, that can be give you different results. This simulation is running. We get those results by running the simulation in MATLAB environment. So the last part I'm going to talk about is network awareness. So in this part, I will talk about the network reduction and network parameter estimation. The first of all, to do the situational awareness, the network model in the simulator is really important. And what we did is the first network reduction is to reduce the complexity of the network, and that will be save computational cost, which can let the simulator calculate more faster. So aggregate, the idea to do the network reduction is aggregate the points and enhance the DR and the load awareness. The distribution, in this case, we did we developed a different algorithms such as equivalent controllable DR resource, and we developed the equivalent controllable load and residual power. We did a way to estimate residual power injection. So residual power injection, that's kind of like kind of part of loss allocation algorithm, and we showed those equation in this slides. The last part I want to talk about is network parameter estimation, as practically some distribution system still, the size of distribution system is still growing, and some utility expand their distribution system. So that requires we update the model in the distribution simulator. But the accuracy of the network model, if we expand the system, the accuracy of the model can be changed. So in this case, we need to use some endpoint data, map those data into our simulator and update our simulator. To do so, we developed a machine learning based machine learning technique to estimate those parameter, and by mapping the AMI data, then we can calibrate the distribution system model to make it more accurate, which can provide a better situational awareness. Yeah, I'll stop here for any questions. Thank you.
Great. Thank you, Xuan. So do we have any questions? Feel free, you can unmute, or you can put it in the chat if you'd like to ask a question. No questions? So, Siobhan, I believe you and your colleagues are going to be presenting some additional information on some of your work
Right.
in the March webinar.
Yes, we're going to present the, I think this behind the meter disaggregation work with that work we did with ETAB and Hawaii Institute. Yeah, we are preparing that.
So why didn't you, can you talk a little bit about what your next steps are related to some of your work in more detail?
Yeah, so currently we have done with the situational awareness, but we are still working on to make more application on that, which we are trying to develop a situational awareness tool, then apply this tool into different cases such as residency-driven restoration, and to see if those tools can give a better, can improve the some cases, like I mentioned, if the situational awareness can improve the restoration or not. That's the work we are doing right now.
Okay. So how do you see the availability of data with that next step you're talking about? Do you feel that the data's there for what you need to do, or is there additional data you'll be pulling in for that analysis and that tool?
Yeah, so the tool is developed by general purpose. We use different data, we pull different data from different utilities. The idea to the validation is we want to try to apply the tool with different utility data and apply it in the different operation conditions. So to see if the idea is to see if this situational awareness is can operate in general, I mean the more universal way. So that is the things we are doing now.
Okay, Sanjeev, we got time for one more question. Go ahead.
Yeah, John. So I think how do we make the generalized models which can't depend on the utility, or I mean, it's just using the data, but when we vary the utility system, obviously the data itself will vary and the accuracy of the algorithm vary. But how do we make a generalized model that can work with at least different utilities in the same region, even though the typical weather varies, but doesn't vary like drastically from this.
Right.
I mean,
yeah, thank you for your question, Sanjeev. I think this is a really good question. So the one of my idea in my mind right now is to implement the reference learning, the Q-learning. This is one the learning method we can use for control and operation node technique. So that's still in my mind. I still need to try and to do more test the case, then I can see if this is working or not.
yeah, thank you.
Yeah, thank you.
Great. Thank you, Tron, and we will put the seminar announcement in the chat. I'll put that during the next talk. I will put that in there so we have that. So
yeah, thank you.
Thank you. We're going to head into our next